Yesterday, computer vision gave AI the ability to see and interpret the world. But what about AI that does not just observe, but acts? AI that takes decisions, makes moves, and learns from consequences. Today, we explore reinforcement learning, the AI that learns by playing. And the story of what RL achieved in 2016 is one of the most jaw-dropping moments in technology history. So what exactly is reinforcement learning? Well, at its heart, it's all about learning from trial and error. Imagine an AI that isn't just passively fed a bunch of data. No, this AI has to get its hands dirty. It has to actively interact with the world or a game and figure things out all by itself. And this right here, this is basically the whole game plan. It's a really simple but incredibly powerful loop. First, you've got the agent, that's our AI. It's living in an environment, say, a game board. The agent takes an action. It makes a move. And then, based on that action, it gets a reward. And it just does this over and over and over again, millions, sometimes billions of times, slowly figuring out the perfect strategy to win. Now, hold on. Does this whole reward thing sound a little familiar? For those of you who've been with us on this journey, think all the way back to episode 2. Remember we talked about training a dog? Good action, you get a treat. Well, this is exactly that same idea, just cranked up to a whole new level. Instead of a dog learning to sit, we're talking about an AI learning to master the most complex game humanity has ever invented. And that game is Go. It's this ancient board game. The rules are simple, you can learn them in minutes. But mastering it? Oh, that is a whole different story. For decades, Go is considered the Mount Everest of AI, the ultimate grand challenge. Just to give you an idea of how insane this is, you think chess is complicated? Chess is nothing compared to Go. There are more possible positions on a Go board than there are atoms in the entire observable universe. Let that sink in for a second. You simply can't brute force it. There's no computer on Earth powerful enough to just calculate every possibility. It's impossible. And that's exactly why, as recently as 2015, all the top experts were saying the same thing. It'll be at least another decade before an AI can beat a human champion. They thought the game required too much intuition, too much creativity, a human touch. Well, they were about to be proven spectacularly wrong. What happened next wasn't some quiet lab experiment. This was a blockbuster event, a clash of titans. It was human intuition versus pure machine logic, and it was broadcast live to millions of people all around the world. In this corner, representing humanity, the living legend Lee Sedol, one of the greatest Go players of all time. And in the other corner, the challenger, DeepMind's AI, AlphaGo, a machine that trained by playing millions of games against itself. So the stage is set. It's game 2 of the 5-game match. The pressure's on. The whole world is watching, completely captivated. You have the best Go masters on the planet commentating, analyzing every single move. And then it happens. AlphaGo places a stone, move 37, and for a second, the entire room just goes quiet, complete silence. The human commentators are just stunned. They're baffled. They actually think it's a bug in the system. One of them literally says on the broadcast that it was a mistake. To every single expert watching, the move looked clumsy, amateurish, a totally wasted turn. And this is the most important part. It wasn't just a clever move, it was an alien move. It was a strategy that went against thousands of years of human wisdom. No human player would have ever considered it. AlphaGo discovered it completely on its own, free from the shackles of human tradition, just by playing itself. And that mistake? It turned out to be a move of pure inhuman genius. It was beautiful, it was creative, and it was the move that completely shattered Lee Sedol's strategy and won AlphaGo the game. That moment changed everything we thought we know about AI. What a story, right? But AlphaGo's victory was never just about a board game. The really cool part is that the very same principles that let it conquer Go are now being used to solve some of the world's most difficult problems. We're seeing this kind of AI teach robots how to walk on tricky surfaces. It's being used to optimize the cooling systems in gigantic data centers to save massive amounts of energy. It's helping to train self-driving cars in simulations, and is even being used to help discover new life-saving drugs. And to bring it right back home, similar techniques are being explored to optimize the unbelievably complex schedules of the Indian railways. I mean, imagine trying to make one of the largest, busiest train networks on the planet run more efficiently.
That's technology with a real, tangible impact.
So look, if you take just one thing away today, let it be this. Most AI needs us to feed it data. Reinforcement learning creates its own experience. It learns by exploring. And because of that, it can uncover strategies and find solutions that no human being has ever even thought of. It can literally learn the unknown.
Reinforcement learning can master any game, optimize any system, and discover strategies humans never imagined. Tomorrow, we enter the most exciting frontier of all, generative AI. AI that does not just learn or decide, but creates. Art from text, music from a description, code from a comment. Episode 11 is tomorrow. See you there.